Hi, everyone. My name is Remi. I'm the founder of Inco. We're a modular confidential computing network. So maybe just to start off, why do we care about confidentiality? So if we want to use blockchain as the value layer for all of us, then confidentiality is important because it's a fundamental human right. The simplest example I can give is you wouldn't want, for example, your neighbors to know how much crypto you own, right? But this is the problem with public blockchains nowadays, is that everything's public. Second is it's going to be extremely hard for institutions and enterprise to adopt crypto if it's completely transparent. And this is because there are regulatory requirements, but also as enterprises, there are also competitive advantages that you don't want to leak directly on chain. And then lastly, you also want to have the ability to build applications that basically requires some confidentiality. So for those who came to Web3 today, you would quickly realize that you can only build use cases that only make sense on a transparent database. But this is not how Web2 works. What if you want to build a poker game? You need to be able to have some confidentiality on-chain in order to enable these other use cases. And so this is where we come in. So we are leveraging a different cryptography called fully homomorphic encryption, FHE. So what is FHE? From a very high level, it's a cryptography that allows you to encrypt data, but also compute on top of it. So imagine you were to encrypt some integers. You can still add, divide, multiply, but also compare them. And for folks who are not developers, imagine if you were to encrypt this cat picture into this pixelated image, you can still modify the RGB values while being encrypted. And when you decrypt, you have this magic filter basically applied to it. So this is really the unique property of FHE. So in the context of privacy, we do have ZK solutions for privacy, but what are some differences here? I would say the biggest differentiation here is the idea that if you apply FHE to blockchain and store the Cypher Tex on-chain, they're also composable. And this is, again, because you can do computation on top of encrypted data. So essentially, in the context of blockchain, this means that you can do state transition. And so if you want to build some kind of multi-party use cases, let's say predictions markets, we can all submit our hidden prediction for the price of Bitcoin and still compute the average without having to decrypt. Now, when you apply FHE to an EVM called fhEVM, essentially what you have is you can have an encrypted state directly stored on chain. So in this example, on the first line, you can see for confidential ERC20, it's just the mapping of address to EUN32. So EUN32 is just an encrypted integer to hide your balance. And if you want to do a ERC20 transfer, you just do a FHE operation for adding the encrypted amount on top of the encrypted balance, and then you're subtracting from the sender, essentially. And lastly, we can also generate on-chain randomness. That's also hidden by default, which can be quite useful for games such as poker or games like Mafia, where you have to generate a hidden roll. So again, here FHE is an interesting solution because as compared to TE, we don't require any centralized hardware. Compared to ZK, we don't have to write any complex circuits. This is all abstracted away in Solidity. And more importantly, for multiplayer use cases, you also don't need off-chain coordination. The blockchain acts as the coordination layer directly. So what is Inco? Inco is two things. First, we are a modular layer 1 blockchain that leverages FHE. And second, we want to extend confidentiality to existing chains. So we want to be the universal confidentiality layer of Web3. Just a high level, the way this works is, we are a layer 1 blockchain, EVM-based, and then there's a FHE Rust library that's added at the precompile level. So this is where, if you need to support encrypted operations, this precompile will be run to, do the FHE operations throughout the execution. For decryption, there is a MPC system. So this is where, if you want to do a decryption, you basically, each validator has a key fragment. They have to do a partial decryption. And you have to aggregate enough of a threshold to decrypt. So this prevents any validator from decrypting decrypting themselves. And the way we bring confidentiality to existing chains is through general message passing. So there are 3 ways we could do this. First, we can do it through IBC because we are a Cosmos blockchain. Second, we can also use external bridges such as Wormhole, Axelar, Layer 0. And then lastly, we will also support a native bridging. And this is because we are built on top of EigenLayer. So as an AVS, these operators could also monitor states on Ethereum. So we will also support native bridging. But the idea is this, right? Most public blockchains will not be able to support FHE because the hardware requirements are quite high. There's also this MPC component. So the idea is we want to bring confidentiality features to existing chain. So imagine if you were to build a game, let's say on Polygon, you can just store some confidential states on Inco. So now about the use cases, right? Why is confidentiality such a big unlock? So we can start with gaming. If you think about games today in crypto, when they're built on public blockchains, you are going to be very limited in the types of games you can build. And this is because all the states are known, right? So for example, in a game of RPG, if I know that you have higher stats than me, why should I ever attack you, right? So if you think about Web 2 gaming, most games that are fun require mechanics that hide certain information, right? So whether it's your stats, whether it's your role. So in a game like Mafia, you actually don't want to reveal that you're the killer or the doctor or the detective. In a game like poker, you also don't want to reveal your cards on chain. And then again, we can also consider resources for a game, RPG strategic game. We can also do bluffing. You can sabotage. So we think we can unlock quite a bit of novel mechanics within the crypto gaming side of things. And the second category is DeFi. So there will be novel primitives as well, because again, today, most DeFi primitives only work if they make sense on a transparent database, right? But what if you want to do something like a dark pool, like a blind auction, or private AMM? You need confidentiality. And so we believe that we can unlock a suite of novel DeFi primitives that could be quite interesting. On the payroll side of things, it's also quite of a helpful or useful feature to have confidentiality, because for those who already pay their employees in stablecoin, you probably face this dilemma where everyone kind of knows how much everyone's making. And this is kind of a bad practice, known bad practice in Web 2. So for us, in the example of confidential ERC20, you can just hide the amount being transferred. And that is essentially bringing in more of a Web 2 experience to Web 3. So something that maybe we all already use is something called Venmo, right? So you can send money to your friends, but people cannot see the amounts being sent, right? So this is kind of like the experience that's more Web 2-like and also necessary for mass adoption. We can also do private cap tables, private treasuries. Mentioned real-time prediction earlier. Private voting is also a quite important use case. Today, if you are part of a DAO, especially if you're one of the executives or KOLs, sometimes it might be very difficult for you to honestly vote, right? Because there could be repercussions on your votes. So a layer of privacy on voting is also a very practical and necessary tool for DAOs. I'll cover the confidential DID in a bit. But yeah, so this is a game that we built during ETHDenver NYC. It's a fully on-chain Mafia game. So for those who don't know what the game is about, essentially it's a game of bluffing. So you could be the killer, or you could also be a doctor and the detective. And the goal of the game is to find out who the killer is. And so for this game to make sense on blockchain, you need to be able to hide the roles. So here it's very simple. It's just the EUINT8 type within a struct. And because of the on-chain randomness that we have, you can also generate the hidden role directly. And so this is essentially a novel experience that's not possible on public blockchains that we have brought during ETHDenver NYC. And here again, with the on-chain randomness, we can enable card games, speculative games. And this is built directly on the chain, the randomness. And then in terms of extending confidentiality to existing chains, you could, for example, build a poker game on Base, where you can make the deposits. You can deposit 100 USDC. You can raise, you can fold. Just generate and store the cards on Inco. And then at the end of the turn, just reveal the cards and settle back on Base. If you want to build an RPG game, you can store the hidden loots, hidden player stats on Inco, and just build the core game logic, let's say on Polygon, for the missions, for the the farming. So this is kind of how we plan on bringing confidentiality through existing chains. So this is also a very good example of how confidentiality can unlock novel ideas within Web3. Today, the IDs are static. They're soulbound NFTs, right? So you will KYC with a third party that will send you some kind of NFT that has static metadata. So are you over 18? Are you based in Europe? However, with FHE, because we can do comparisons over encrypted data, we can have this idea of a more dynamic or programmable layer DID. So for example, I could encrypt your credit score, store it on chain, and do FHE comparisons to reveal whether your credit score is about 700, or for example, for your age, it could be your date of birth, convert to timestamp, and then encrypted, stored on chain. And then you as an end user, you can basically toggle which insights you want specific applications to query. So maybe for a casino dApp, I just want you to know I'm over 18 and nothing else. So it's a very, again, it's a very much Web2-like experience, similar to Google Auth, where maybe I just want you to access my calendar, but not my Google Drive, right? So the way this works in code is very straightforward. It's one line of code here, tfhe.gt, meaning greater than. All you do is you compare your credit score, whether it's above 700. And then from there, you just do a decryption. And the way this could work in practice is, imagine you have a money market on Polygon. You want to only allow users who have good credit scores to use it. Then you could request this DID layer built on top of Inco. And then as a callback, you can then whitelist the user based on insights that you have generated. So we are compatible with existing Ethereum tooling. So you can get started within 20 minutes if you're a Solidity developer. You can use Hardhat, Remix, MetaMask. You can do a pretty wide array of operations and comparisons over encrypted data. So this is really helping you unleash your creativity. You can build across DeFi, gaming, because of it. So we can do additions, subtractions, multiplications, divisions. You can also do all sorts of comparisons, right? This is the example of the DID. You would just do comparisons on specific insights that you want to expose as an end user. To get started, you just have to import a line of code. This is a screenshot from Remix. One thing to note is building confidential dApp, you have to slightly think differently because you don't want to leak information. You don't want to leak hidden information in your logic. So for example, if you were to have if and else statements on top of encrypted data, the path of execution could potentially leak what the information is, right? So the way to go around this is there is a multiplexer function called CMUX. So what CMUX is essentially similar to a ternary for people who code in, let's say, in JavaScript, right? So the idea is on the first line of code, what you do is you see whether the encrypted choice is equal to 0 or 1. So here you compare to 1. What you get is an eBool, which is an encrypted Boolean. With the eBool, you don't know if it's true or false. It's encrypted. You pass this eBool into this CMUX function that returns the first argument if it's true, and the second argument if it's false. So the first argument here is the encrypted vote count, and the second argument is 0, but 0 is also encrypted. So essentially, on the second line of code, you don't know if it's 0 or the actual encrypted vote count. You do the same thing for against countercast, but it's reversed, right? So you return 0 if it's true, and then the encrypted vote count if it's false. So one of these two values would be 0, and the other one would be the actual vote count. And you have both of them to their respective tally, right? So this is how you would build confidential applications without leaking information. And then there are two decryptions. So one is a decrypt function where the encrypted data is revealed to an entire network. So very useful for games like poker, right? At the end of the round, you want to decrypt all the cards, reveal everyone's hand, and then settle the hand, right? The second one is more of a view function called re-encrypt. The way this works is on the client side, you generate a temporary private key and public key pair, and you pass in this public key inside this view function. So the validators, they will basically use their key fragment to do a partial decryption and immediately re-encrypt using this public key. So all this information is sent back to the browser. you basically use that private key to decrypt, and then use the threshold decryption to reveal the plain text in a safe manner. So the way to store a Cypher Tex, essentially, so a Cypher Tex is the way you hide data in our system. A Cypher Tex essentially is composed of data padding, some data, the plain text data, some noise, and some noise padding. So you generate this on the front end with the front end clients. You encrypt this using the global FHE key of the system, and then you pass this information on chain, right? So this is kind of like the flow for interacting with the blockchain. And yeah, so lastly, we are sponsoring ETHDenver Hackathon. We have a few bounties. And for us, we would really like to see folks basically building novel use cases that aren't possible on public blockchains, and really kind of try to push for the next frontier of dApps and bring in novel experiences similar to the Mafia game that we built to the space. We have a Notion page with a list of ideas that we think are a little bit more interesting and novel based on the capabilities that we can offer. So feel free to check out this page. Also, if you want to talk to us, talk to the team, feel free to join our Discord. We're pretty active. We're happy to provide feedback on your hackathon ideas. Also, just if you just want to jam on new ideas. And we also have essentially a advocate program, also builders program, where if you're interested in building with us on the long term, we're also happy to work with you very closely. So Telegram group, and then we launched our testnet a few days ago, so you can get some testnet tokens and start playing with it today. And yep, that's it. And if you want to find more information about us, here are the links. We also have some demo dApps that you can play around. If you come by our booth, we'll also have this iPad that has a bunch of mini dApps that you can try around, play around. Please follow us on Twitter. And lastly, there is a secret game that we're going to release during this hackathon. It's essentially a 2/3 guessing game. So the idea is everyone gets to guess a number between 0 and 100. And the winner is the person that gets the closest to 2/3 of everyone's guesses. So this is also to illustrate kind of like the capability of what we're building here. Is just the idea that we can still compute the average of everyone's guess without having to decrypt using FHE. So yeah, we'd love to have everyone come try it out. We'll be at the booth. Yep, thank you.